Right. All right, ladies and gentlemen, in person and on Instagram Live and on Facebook, thank you for being here. My name is Deron Johnson, and this is Master Your Metabolism. This is a deep, deep dive into metabolism. So before we get into the content, I want to tell you a little bit about how the class came about. So before my foray into the fitness and nutrition world, I was a software engineer for 13 years. It was 13 long, hard years. I got some software engineers with me on Instagram right now, so you know. So my job as a software engineer, I fixed things, I built things, sometimes I broke things. But what I really did, the essence of my job was I solved problems. And I realized very early that for me to be the most effective at my job, what I needed was a lot of information about the problem, but I also needed quality information about the problem. So a lot of quality information was needed for me to do my job effectively. So as I transferred my problem-solving skills from the boardroom to the weight room to the kitchen, and I started helping my clients and my friends and my family solve their nutrition problems, I said, okay, this is what I need. I need quality information. I need lots of high-quality information. But I realized very early that getting high-quality nutrition information was very hard. There's information that people are getting from all kinds of sources. You think about it. You go to the grocery store. I don't know if they still have magazines at the checkout line anymore, but if you go to the checkout line at the grocery store, you're going to see 5 different magazines with 5 different slogans and ways how you can change your body. This one magazine will say, all right, eat this superfood and you lose 20 pounds in 5 hours, you know? And then another magazine might say, eat this herb, sprinkle this herb on your food, you'll be able to do a backflip in 10 minutes. So we're getting all these claims, and it's getting worse with the internet, you know, because the internet is just growing and growing, but you can't discern anybody can put information on the internet. So I realized that my clients were having a very challenging time figuring out the information and what was good, what was great information, what was lousy information. So I put it upon myself. I made it my mission. I made it my goal to make sure that I dive deep into the science of nutrition and then put it in a palatable form so people could understand it. Because I realized people have jobs and kids and pets, and they just don't have the time or the knowledge to dive into a research journal, a peer-reviewed research journal, and read a 50-page study on high fructose corn syrup. People don't want to do that. So I decide I'll go into the science, get all that information, make it palatable for people. So that's what I made my mission in life, to do that. The other thing I realized as I transferred into the nutrition world is that most of my clients were dealing with the same issues. They were dealing with the same problems. Have you heard of the Pareto principle? The Pareto principle is the 80-20 rule. You might have heard of it. We get 80% of our results from 20% of our efforts. So for example, you might wear 20% of the clothes in your closet 80% of the time. Or if you have a company, maybe 20% of your employees are bringing in 80% of the revenue. So I realized that there were 80% of my clients were stuck on the same 20% of these core nutrition issues that they were dealing with. So everybody was dealing with the same thing. So as I started compiling what people are dealing with, I just started making notes and notes and notes, and eventually I had enough of these notes to start making classes. So this is one of the classes, Master Your Metabolism, because I realized that 80% of my clients were stuck on metabolism and understanding it and how they can use it to win their weight management battle. Whether they wanted to lose weight, gain weight, whatever they wanted to do, we need to understand metabolism at a fundamental level. So that's what this class is. This is a deep dive into metabolism. We'll talk about what metabolism is. If you think you have a fast metabolism or a slow metabolism, we'll see. We'll see if it even matters. And we'll talk about why your metabolism might be the way it is. And we'll talk about how you can measure it. We'll also talk about how you can change it. So before we get started, I do want to hear from you. What is your idea of metabolism? So if somebody asks you, what's metabolism? What do you tell them?
How efficient you can burn your energy.
So how efficient you can burn your energy. Okay, that's a good definition. Anybody else have a different idea? Doesn't have to be right. I just want to hear what you're thinking.
Well, I was basically going to say that, but how fast or slow you do it.
Okay. So how fast or slow you create
burn that energy.
Got it. How fast
those calories, how you eat, and some people can burn it fast. I guess that's what they say, and then they're always going and they're thin, and then others are more sluggish.
Gotcha. So it's the speed at which that happens, which is the critical point of metabolism. Gotcha. Anybody else have an idea of what metabolism is? Well, I want to give you a very simple definition. Did you have something to say, Margot? Or are you just drinking your tea? All right. She said, just leave me alone. Let me drink my tea. All right. So a simple way we can define metabolism is simply the sum total of all the processes that are running in your body at any given time. So another way to think of a process is a task. What's some things that your body is doing? So right now, under the hood, our heart is beating, our lungs are taking in air and expelling carbon dioxide, our eyes are blinking, our brain is taking in information. That's a task. And there's tasks that we know that are happening, there's tasks that we know are not happening, that we might not be able to feel. But all of these tasks that our body performs, they need energy to perform the tasks. So if you have more tasks running in your body, or they're running faster, as we'll talk about a little bit later, or they're running slower, they might require more energy to perform them. So more tasks that are running in your body equates to more energy that is needed for those tasks or processes to run. So if we have these processes that are running in our body and they need energy, where do we get our energy from? Food, that's right. That's one place we get our energy from food. We get our energy from food. Where else might we get energy from if we didn't have food?
Sunlight.
Sunlight is actually where the food gets its energy. So indirectly, yes.
Okay.
So we have food, we have sunlight. Where else might you get energy? Sleep is another way we can indirectly get energy. But if we wanted to get calories for our body to do something, where would we get that energy if we didn't have food? So let's say you didn't eat. Where would your body get energy? Fat, yes. So stored fat is the very optimistic answer, yes. So in general, we would get energy from our bodies. So that's where we get energy from our bodies. But we also get it from food. So let's talk about why we eat. We get our energy from food. I want you to think about something that you ate today. Maybe it was a bagel, maybe it was Twinkies, hopefully not. But think about, let's say it was a bagel. This bagel, if you looked at it with a microscope, you would see millions and millions of tiny, tiny molecules. So it's not just one big bagel, it's millions of molecules that are connected. And all of those molecules are connected by what's called a bond or a chemical bond. So think of a bond as a tiny stick of dynamite. And we know that dynamite has an extraordinary amount of energy that's stored within it. But that energy is only available when we explode the dynamite. So the same thing happens with these chemical bonds in our body. The chemical bonds are tiny sticks of dynamite. And what explodes the dynamite, what breaks the dynamite, are the digestive enzymes in our body. And that's how we get energy. So we take in large components of food. The digestive enzymes break those larger components of food into smaller components. When that happens, those dynamite sticks, those tiny dynamite sticks get exploded, and we get energy from that. And that energy gets redirected, and that energy in the redirected form, that's what gives us the energy to power all of these processes that are running in our body. Our heart beating, and our lungs, and walking and exercise. It's all about the energy that is in the chemical bonds that connect the molecules of these large pieces of food. So that's the first reason we eat. We eat for the energy. But there's a very important reason why we eat also. And the reason we eat is because what our bodies do all day, every day, is they create and take apart jigsaw puzzles. Jigsaw puzzles like you see here. Now think of the jigsaw puzzles in our body. They equate to anything in our body that is functional. So anything in our body that performs a task. So it could be an enzyme, it could be a hormone, it could be your DNA, it could be your hair, your nails, your muscle. All of these are puzzles that your body puts together, and these puzzles have a certain function. Now some of these puzzles are very small, 4, 5, 10 pieces. Some of these puzzles consist of 10,000 pieces or more. So for the sake of illustration, let's talk about how our body might put together a puzzle. And this puzzle is an enzyme. Let's say it's an enzyme that gives you energy. And this puzzle consists of 4 pieces. It consists of an amino acid. Let's call it amino acid A. Where do we get amino acids from, by the way? Proteins, you got it. So let's say this puzzle is 4 pieces. 1 piece is an amino acid. We'll call it amino acid A. 1 puzzle piece is vitamin B. Another puzzle piece is iron, a molecule of iron. And then we have another amino acid. Let's call it amino acid X. So in order for our body to put together this puzzle, it's going to look for all these puzzle pieces in the food that we eat. And so let's say your body wants to put this enzyme together. It's going to look through everything you ate, everything you stored, and say, okay, we're looking for amino acid A. Do we have it? Great, let's put it in the puzzle. We're looking for vitamin B. Do we have that? Let's put that in the puzzle. And then iron goes in the puzzle. Then amino acid X. So when your body has all the puzzle pieces, now the puzzle is complete. Now you have this enzyme that creates energy for you. So what happens in the case where we have a deficient diet? Let's say we don't eat a lot of green leafy vegetables, so we're deficient in vitamin K. So now your body wants to put this enzyme together. It finds amino acid A, perfect, puts it in the puzzle. It finds vitamin B and puts that in the puzzle, and it finds your molecule of iron, and that's in the puzzle. But where's the vitamin K? Remember the 4th piece? Well, this isn't it. So let's say it's amino acid X that's missing. So it looks for amino acid X, and it can't find it. It can't find it. It can't find it. So now this puzzle is not complete. Your enzyme is not completed, and now you don't have this crucial enzyme to give you energy when you need it. So this is a simple illustration, but the point is that when we create a diet that is deficient in some way, we're going to have a lot of puzzle pieces that are potentially not created. Your body might say, okay, I'm not going to create this enzyme puzzle because I don't have the puzzle pieces. Your body might say, I'm not going to create this DNA repair enzyme because I don't have the puzzle pieces. And then we get this DNA replication error, and then that could lead to cancerous implications down the line. Your body might say, I'm not going to create this muscle cell because I don't have the puzzle pieces. So when we have a diet that's deficient, our body can suffer and lose its functionality in indeterminate ways. So if all of us are deficient in vitamin K, our body might manifest that in very different ways. So what that means is that we want to eat not just for the energy, but for the puzzle pieces, for the things that it contains, the vitamins, the minerals, the protein, the carbohydrates, the fats, all of those things. That's why we eat. It's not just for energy. It's for the things that are in the food that can help us put together our body in a very efficient way. Does that make sense? Okay. Any questions on that before we move on? Okay. And what I'll do for Instagram Live at the end, we'll answer some questions at the end. We got about 30 more minutes here, but I'll answer a bunch of questions at the end. All right. Let's go into metabolism. How many people here think they have a fast metabolism? How many people think they have a slow metabolism? How many people think their metabolism left the body 15 years ago? Okay. So the good news is that whether you think it's fast or slow, it doesn't quite matter, because when we say fast metabolism versus slow metabolism, that's a relative term, not an absolute term. So fast or slow only means something when we compare it to an equal. So that means that if you had an identical twin, and your identical twin had the same age, height, weight, and gender, and let's say your identical twin, her heart was beating 5 beats a minute faster. And let's say her lungs, their breathing rate was 5 to 10 breaths per minute faster. Maybe they fidgeted more when they were in their chair, when they were sedentary. Maybe they ruminated a lot. They were always thinking about things, so their brain was always going. Those are the processes we talked about in metabolism. So those processes, as you said, Marjorie, those processes are running faster. So your identical twin would have a fast metabolism relative to you, and yours would be slower relative to her. But it doesn't mean yours is absolutely fast, or yours is absolutely slow and hers is absolutely fast. If you compare your metabolism to mine, they're going to be drastically different. It doesn't mean that yours is slow and mine is fast. So when you think, whether you think you have a slow or fast metabolism, that's not the critical path in how we create the strategy for your weight management, wherever you want to go, whether you want to gain weight or lose weight. It's not whether you think you have a slow or fast metabolism, it's how we measure it. And This is one of the first, when I first started measuring metabolism, and I'll talk about how we do it, this is one of the aha moments, one of the breakthrough moments that really changed how I operate in the nutrition space. I had a woman who came to me, this is in 2009, and she was gaining weight rapidly and she didn't know why. And she came to me, she wanted to lose weight and figure out how to stop this increase of weight that was happening. So at the time, this woman was 43 years old. She was 5'6" and she was 218 pounds. And she was gaining weight rapidly. So if you meet somebody and she comes in and she says, he or she, and they say, I'm 5'6", I'm 220 pounds, and I'm gaining weight. Are you thinking intuitively, are you thinking slow metabolism or fast metabolism? What are your thoughts?
Intuitively,
Yeah,
I'd say slow.
intuitively slow. Most people thought slow. Yeah, absolutely, and I thought slow. So I measured her metabolism. I measured her resting metabolic rate, which in a way that we'll talk about in a little bit. And if this woman sat in a chair, just like you're doing, and did nothing all day, she was burning 2,318 calories. Now, does that sound slow or fast to you? That sounds fast. However, she thought it was slow. I thought it was slow. The world thought it was slow until we measured it. So it's not. So this is actually a good time to go into the components of metabolism. What is metabolism? There are three major components of metabolism. What we measured is called her resting metabolic rate. This is the largest component of metabolism. And this is what your body needs just to sustain life. So this is the energy that's required for your body's heart to beat, and for your lungs, and for your organs to function, and for your immune system to perform. Everything just taking care of your life functions. That's the first part of this. This is called resting metabolic rate, and this is the largest component of metabolism. The second component is your activity. So if RMR, resting metabolic rate, is what you do before you get out of bed, activity is what you might do when you get out of bed. So you're getting up, you're cleaning your house, you're walking to your car, you're food shopping, you might have an active job, maybe you're a landscaper, maybe you're a plumber, maybe you're an office worker, sedentary 2,000 to 3,000 steps a day. So this activity component is a multiplier of your metabolic rate, and it changes from person to person. Now that's the second component of activity, second component of metabolism. So first you have resting metabolic rate, then you have activity. And then the third component is any exercise that you might do. So when you add all of these up, this is how many calories you'll burn in a day. It's your resting metabolic rate plus the activity you perform when you get out of bed, and then any exercise you perform. So to make my case study a little more accurate, remember, I measured my client at 2,318 calories. That was just her resting metabolic rate. When you factor in activity and exercise, this woman was burning well over 3,000 calories a day. So I had to talk to her and say, look, if you're gaining weight consistently and rapidly, and you're burning 3,000 calories a day, there are the majority of your days where you are eating above 3,000 calories. So before we talk about how to lose weight, let's understand your situation. Understand, how are you eating 3,000 calories or more a day? And as we went into the investigation, not only was she eating more than 3,000 calories on most days, she was eating 70% of them at night because she had a very stressful job. She didn't eat much. She just grazed during the day on simple things, and she went home and ate anything that was not nailed down. So the strategy for her weight loss, which she wanted weight loss. So the strategy is dictated on how we measured her metabolism, and it's the fact that it was fast. If her metabolism was very slow, the strategy might be, okay, let's do some things so you can burn more calories throughout your day, or maybe exercise in a way that you can increase your caloric output and you can burn more fat. But she was burning 3,000 calories a day. The last thing she needed is, on top of a very stressful lifestyle, the last thing she needed was 5 days a week of strenuous exercise that's only going to have her burn 200 or 300 calories more than she's already burning. So I said, look, your metabolism is already sky high. Let's figure out how we can eat below that. Not much below that, just a little bit below that comfortably. And if we can do that consistently, your body's going to burn it. You don't have to do more activity. So we changed her diet. She ate a little less than she was burning. and the weight was falling off like clockwork, rapidly, consistently. So the strategy, if we would have based our strategy on the fact that she had a slow metabolism, we would have had to raise her metabolism, do things, exercise more. But it was the measurement that counted. So we realized she had a fast metabolism, and now the strategy is based on that. She doesn't have to burn any more calories. She's burning plenty. Does that make sense? So it's really, think about whatever you think is going on. It might be the case, but here we use science to verify whether it's the case, and then we let science and data dictate our approach. Any questions? Okay. All right. So metabolism, yes, it can be fast in the short term or fast in the long term. So if you think about it, the processes that are running in our body, they can run faster or we can have more of them. So for example, during exercise, your heart's beating faster, your lungs are taking in more oxygen, your body's moving faster. So the processes that are happening in your body, they're running faster. So in the short term, your metabolism is faster. Also in the short term, there's a way we can increase our metabolism, and it's called EPOC. It's called the excess post-exercise oxygen consumption. And that refers to the spike in metabolism and calorie burning that happens after an intense bout of exercise. Have you heard of interval training before? So interval training has been shown to raise that EPOC, excess post-exercise oxygen consumption. So in the short term, we can raise our metabolism. But what we're looking for, if we're looking for persistent results, we want to think about how can we raise our metabolism in the long term? If you're exercising, that's only 1 hour a day, maybe 2 hours a day. How can we increase our metabolism for the long term, the 20 plus hours a day that we're not in the gym? How can we increase our metabolism there? That's where the magic happens. So one quiz for you, and at home I want you to think about this answer. We eat 3 basic components of food. We eat protein, we eat carbohydrates, and we eat fat. As you sit listening to the lecture, you're burning one of these more as a percentage. So we're either burning more protein, more carbohydrates, or more fat as a percentage. So how many people think we are burning more protein as a percentage, more than the others? So nobody thinks we're burning more protein. Okay. How many people think we are burning the majority of our calories right now from carbohydrates? 3. How many people think we are burning the majority of our calories from fats?
Depends on your activity.
Right, so it depends on activity, but I'm talking about as you're, so if we're resting right here, yes. So as you're resting, as you're in a minimal activity state, are you burning more protein, more carbohydrates, more fat? I saw a few people for carbohydrates, nobody for protein, nobody raised their hand over here.
I say it depends. I say it depends.
Depends, okay. Depends on what?
Well, did you just eat a bunch of carbs and now you're burning them off?
That's a good question. Let's say you didn't eat. You came in here, you haven't eaten anything, and you just sit down. She thinks it's going to be fat. What do you think?
I think it's going to be protein.
Protein, okay. So the answer is when we're at rest, we are burning more fat as a percentage than carbohydrates. And here's why. Leah, great job. Here's why. Fat is a very large molecule. It's a long hydrocarbon chain, so it's a bunch of carbons, up to 18 carbons, with hydrogens attached to them. Now, when we have this large molecule, it takes a lot of time to break up this molecule into small chunks and then feed it to the energy systems to get energy out of it. So a large molecule requires a lot of time to chop it up for energy. So when we're at rest, we're able to do that. Think about a time when we're not at rest. Think about when you're exercising. We don't have time. Your body needs energy quick. It needs it fast. Our body doesn't have time to chop up these large fat molecules and use them for energy, especially at higher intensities. The higher your intensity, the more carbohydrates you're going to be using. So when you're at a high intensity exercise or high intensity activity, your body doesn't have time to chop up this fat molecule. But fortunately, we have a molecule called glucose. It's a 6-carbon chain, very small, And our body could virtually feed it in intact to the energy systems and get energy from it fast. Now, you don't get as much energy from a glucose molecule than from a fat molecule, but you can get it quickly. So that means when your activity is at its highest, your body's going to be using more carbohydrates and less fat. When your activity is at its lowest, your body would love to use fat because it has the time to chop it up and you get a lot more energy from it. So that's important because when we're at rest and we're burning fat, if we're burning most of our fat at rest, it's not what we're doing in the exercise. And that's one of the biggest misconceptions. It's not necessarily the calories or the fat we burn during exercise. It's what we're doing in that exercise to set up the calorie burning for the rest of the day. So let's look at this graph. Let's say we all burn 2,000 calories in a day. And in 1 hour of that day, we have a workout and we burn 500 calories. That's actually a monster workout. That's a lot of work. So if we're burning 2,000 calories a day and 1 hour of that is a 500 calorie exercise, then the rest must be 1,500 calories. 1,500 plus 500 equals 2,000. So remember, when our exercise activity is at its highest, we're going to be using very little fat. We will burn some fat in high intensity activity, but it's not as lot as many people think. So let's say we're burning about 20% fat in this exercise bout. So you had 1 hour of burpees and sprints and backflips and burned 500 calories, but 100 calories you burned as fat. Now let's look at the other 23 hours of the day. So you're burning your other 1,500 calories in this 23 hours. At rest, we're burning between 40 and 60% of our calories at fat on average. Sometimes lower, sometimes higher, but average 40 to 60%. 40 to 60% of 1,500 is between 600 and 900 calories. So do you see the difference here? In your exercise, you might have burned 100 calories, but during the rest of the day, you burn 600 to 900 calories of fat. This is where the magic happens here. So the task becomes, what do we do in this hour to make this number bigger, to make this 1,500, to make this 1,600, 1,700, 2,318 like my client? That's what we want to get to. So if we're looking to burn fat, we want to figure out how we can maximize this long-term metabolism rather than the short-term. This is important, but it's this guy, the 23 hours of the day that we're not exercising. That's where the magic happens. Does that make sense? Any questions about that? It's a concept that it shocked me when I really got into it because I thought we went to the gym to burn fat. And we do, but it's just not the percentage of fat that we burn through the rest of the day. Even through a large workout, it's a small component compared to what we do here. All right, so let's talk about why your metabolism might be slow or it might be fast. Any ideas? Why is your metabolism the way it is?
Is it because of your heart rate?
Okay, and what determines your heart rate? So what determines your resting heart rate?
Well, I think if you're pumping your heart as hard as you can, you're basically using all the tissues that you're moving, and they require oxygen and they need energy, and that's related to your metabolism. Okay, so you're basically saying it's activity. Activities, your resting heart rate too. Okay, yeah. And resting heart rate, got it. Any other ideas why your metabolism might be the way it is? Genetics. Good answer, Margot. Food, maybe, yeah. Your activity. Your sleep. Body temperature. Yeah. All those are factors. Let's go into the main ones. Those are all great answers. Genetics. That's a big part of our metabolism. So, genetics refers to the actual DNA sequence in the 23 pairs of chromosomes in our 30 to 50 trillion cells in our body. Now, our genetics, this DNA sequence, we can't change, unfortunately. Think about you buy an iPhone. You open it up, you turn it on, and then there's a bunch of apps on the phone that came with the phone. And then maybe some of these apps you try to delete, and the phone just does that shake where it doesn't allow you to shake, where it won't allow you to delete anything. So you have these apps on the phone, and no matter what you do to try and delete the apps, the operating system won't let you delete these apps. That's essentially your genetics. They're the apps on the phone that you cannot remove. Has anybody here heard of epigenetics?
Yeah, I was just...
What is epigenetics, Margot?
That's how your genes are expressed based on your environmental inputs that can change the way your genes are expressed.
That's exactly right. Epigenetics refer to the environmental factors that modify gene expression. There's a lot of them. There's the things you eat, there's your environment, smoking, drinking, stress. All these play a part in the expression of your genes. So if we were to look at the phone analogy again, yeah, you have these apps on your phone that you can't remove. But you can turn those apps on and you can turn those apps off. That refers to your epigenetics. So with your genetics, you can't change them, but you can turn them on and you can turn them off. And that modifies how your body functions. So the important part of this is to understand that you are not necessarily a slave to your genetics. Because a lot of people, they blame genetics for their shortcomings or the fact that they can't lose weight. And they'll come to me and say, you know, my mom was heavy, my dad was heavy, my dog was heavy, my fish were heavy, everything in the house is heavy. I say that could be the case, yeah. But what if everybody in the house, including your dog and your fish, were eating the same horrible foods and you were just having the same response to that? So there is definitely a genetic component. But sometimes when people blame genetics, they remove the proactivity from changing their course. They say, well, I'm not even going to go on a diet because everybody in my house was heavy. It's just going to be futile. Or I'm not going to try to lose weight. I'm not going to exercise because genetics is holding me back. So what I would recommend to those people is that you change everything about your routine that you can. Change the way you eat, change the way you sleep, optimize your exercise, optimize your nutrition. And then when you have tried everything and nothing has worked, then you can call up mom and dad and say, you suck. I hate you. But I'm not saying that genetics doesn't play a part, but it would be very, very beneficial to not let that be the roadblock and investigate it. And that's what we're here for. So stress, very changeable part. This is also technically an epigenetic modification. In fact, stress can modify up to 25% of your human genome. So that's a ton, that's a quarter of your genes. Now, the biggest thing we can change, one of the big things we can change is our lean mass, our muscle tissue. That's one of the biggest levers that we have the most control over. So why is it that your muscle mass, why does that govern metabolism so much? Because in your muscle, we have these tiny organelles that are called mitochondria. You might have heard of this from middle school biology. Yes? So what mitochondria do is they take in oxygen from the air, the oxygen that we're breathing in, and with that oxygen, remember we talked about digestion and how we break down bigger components of food into smaller components. So that oxygen is the mechanism that we can break down to a lesser extent protein, to an increased extent carbohydrates and sugar, but to a large extent we burn fat with this oxygen. That's what these mitochondria do. These are fat burning furnaces. So the oxygen that we take in enables the mitochondria to convert this fat to energy. So the more mitochondria we have in our body, the more of this fat that we can take in for energy. More mitochondria, more capability to burn fat. Now, muscle tissue happens to have a tremendous amount of mitochondria. So what does that mean? That means that if we can increase our muscle, then we increase this mitochondria, because the mitochondria in our muscle will replicate based on demand, based on challenge. So if we use, just like anything in our body, if we use it, we're going to provide the stimulus for it to change. So the more of this muscle that we can build, the more mitochondria we will create in our bodies. If we have more mitochondria, we have more of this mechanism to burn fat. So think of that mitochondria like a furnace. If you have a giant furnace, you can put in more fuel and it'll burn more. If you have a tiny furnace, you can't take in a lot of fuel. It's not going to give you a lot of heat. It's not going to give you a lot of energy. So our goal is to make our furnace as robust as possible. It doesn't mean being a bodybuilder, but it means maintaining and being proactive about keeping and maintaining your muscle and building it. That's very important for weight management. So this last arrow here, this is carbon dioxide. So as your mitochondria takes in the oxygen, the waste product that it releases, or the end product, is carbon dioxide. So what I want you to do is, you're already doing it, take a nice deep breath in, and then exhale. Congratulations, you just burned fat. So when we burn fat, where we're getting it from, that end product, we're burning the fat, that fat is actually leaving our body through the carbon molecules in our breath. Mind blowing, I know. So you're burning fat as you breathe. And that's the long-term thing. That's what we're doing 23 hours a day. Yeah, we're burning fat. So muscle. It's in many of our cells. There's certain cells that don't have mitochondria, like red blood cells. Red blood cells don't have any mitochondria, and that's why we need a continuous amount of glucose, because they can't use fat for energy. So it's pretty high in muscle tissue. Now, the key thing is the third bullet. Use it or lose it. And this is very important, because if we do not use our muscle, our body will go to great lengths to get rid of this muscle. And you might be thinking, well, I worked so hard for this muscle. I went to the gym 5 days a week, and I drank protein shakes, and I went to bed early. Why would my body want to get rid of this muscle as fast as I put it on? But there are some very important evolutionary reasons, whether you believe in evolution or not. There are some very important reasons why your body will get rid of muscle and put fat in its place. Number one, fat has more energy than muscle. Muscle is water, 70% water, but the largest non-water component is protein. So if we look at energy, protein energy, carbohydrate energy, fat energy, for every gram of protein we consume, we get 4 calories from that. So a gram, and if you start looking at nutrition labels, you'll be able to do the math and see it. So for every gram of protein we consume, we get 4 calories of energy. For every gram of carbohydrates we consume, we get 4 calories of energy. For every gram of fat we consume, we get 9 calories per gram. So fat gives us twice as many calories per gram, or twice as many calories per gram. So that means your body, in times where we as humans did not have food available to us, like this constant supply that we have now, our body's fed off of itself, like we talked about. And our bodies want this high energy source to feed off of for longer. 9 calories per gram versus 4 for carbohydrates and protein. So our body really wants this high energy source available to us. So it's always going to try and put on fat. The second thing is that fat is not stored with water, or it's stored with a minimal amount of water. When your body stores carbohydrates, your body stores it in a form of what's called glycogen. And for every gram of carbohydrates that your body stores in the form of glycogen, your body stores about between 3 and 4 grams of water with it. So every carbohydrate that you store, you're storing 4 times the weight of that in water. So that turns out to be very heavy. And then your protein, that's your muscle, 70% of that is water, as opposed to fat, where maybe 10 to 15% is water. So think about from a survival standpoint. Think about you had 2 buckets of sand. You have a bucket of dry sand, and then you have a bucket of wet sand. Bucket of wet sand, really heavy, not a lot of energy. You have the bucket of light sand, of dry sand, very light, lots of energy. So if you're trekking through the desert for days, which would you rather have? Would you rather have the light energy source or the heavy source that doesn't have much energy? Most people go for the dry sand. It's more energy and it's lighter. So that's why your body wants to, because your body is always acting in this, we're still running this prehistoric software, but it's 2022. But our body is still acts as if we're prehistoric people. So it's acting as, okay, we might not have food available to us. Let's put on this high energy, lightweight energy source, this robust energy source. The third thing is that fat cells Well, muscle cells are a lot more metabolically active. That means you need energy just to maintain them, and fat cells are the opposite. So, anybody here have a dog as a pet? You got to walk the dog, you got to pet the dog, you got to groom the dog, you got to feed the dog, you got to play with the dog. A lot of energy required as a dog owner. How many people have cats? Cat sits in the corner, fat, dumb, and happy, don't got to do much. Your muscle cells are the dogs, and your fat cells are the cats. So your body, from a survival standpoint, it doesn't want these high energy dogs that don't provide a lot of energy and they weigh a lot. Your body doesn't want that. Your body wants cats. Lightweight cats that provide a lot of energy and don't require a lot of maintenance. So your body's always going to try and get rid of the muscle, and that's why we have to be very, very proactive to stimulate this muscle and to grow this muscle. Very, very important, especially as we age. So I think we figured this out, but how do we increase our metabolism in the long term? The first thing is we build our muscle, or we make it more active, meaning that we maintain the muscle that we have. Very important. And you can do that in many different ways. You can do that with strength training, you can do that with interval training, it could be in the gym, it could be body weight stuff, but we have to figure out how to stimulate that muscle. Because if we don't stimulate it, so somebody might say, well, why don't I just take in a lot of protein and a lot of calories and build the muscle? That muscle is only going to build when there's a stimulus, when there's a challenge to it. And that stimulus has to be intense enough, and it has to be repeated enough to get the adaptation. So if we're strength training 10 minutes one time a week, it might be intense, but it has to be repeated. And the amount that we repeat that stimulus and the intensity of that stimulus will be different from person to person. If somebody just started training, maybe they can get away with one time a week because their body is going to take time to recover. If somebody's been training for multiple years, they might have to train longer and much more repeatedly. So building the muscle, it means making it active, stimulating the muscle. So we stimulate the muscle and then we feed it, support it with nutrition. So we said that our muscle is about 70% water, but the largest non-water component is amino acids from protein. So if we're looking to build and maintain our muscle, our protein is going to be the most critical component of the diet. And I don't care where you get it. You can get it from plants, you can get it from animals, you can go out and eat weeds and eat rocks and dirt. It doesn't matter. But we got to make sure that protein is there to support the muscle. And the other thing is adequate calories. Your muscle is like a plant. If you don't feed that plant, it's going to die. So, and this is important because a lot of people go on these crash diets. These crash diets where they're going on a wedding and they got to lose 20 pounds in a week and they eat nothing but styrofoam beads and lettuce for 2 weeks and then they drop this quick weight. But remember we talked about before, when we burn calories from our body, fat is the very optimistic way that we burn. That's the way we would love to burn our calories. But in reality, we actually burn a lot of calories from muscle when we go on a crash diet. Let's go into an illustration. What happens if the calories are too low? So we just talked about that. One thing your body can do is it can adjust its output. It can lower its output. So that means that if you have a certain amount of processes that are running in your body that require energy, and you're not getting the energy to run those processes, one thing your body can do is say, well, I'm going to turn down the volume or the speed of these tasks. So I'm not going to do certain things in this speed. Or it could say, I'm going to turn off some tasks completely. And then the functionality of your body tends to suffer. So your body can adjust. Even if we go on a low-calorie diet, our body can adjust its activity even lower. So the net result is that it's the same calories that are not burned. Now, what does happen, the perfect scenario is that we burn this deficit as fat. So if you burn 2,000 calories a day and you eat 1,500, there's a deficit of 500 calories. And in the perfect world, we would be burning all of those 500 calories as fat. But that is not the reality. The reality is, we actually burn a lot of muscle in a crash diet. So remember, if we lose muscle, we're losing our metabolism, we're losing those mitochondria. So let's go back to this guy. So remember, these mitochondria burn fat. When we build muscle, we increase the mitochondria, we increase the capability to burn fat. If we lose muscle, then we lose the mitochondria, we lose the capability to burn fat at rest. So that's why it's important to keep that muscle. And remember, I did mention stress. Stress is very important for your metabolism because when we're stressed, we release a hormone called cortisol. You've heard of cortisol before? Now, the way cortisol works, that's called a glucocorticoid. And that glucocorticoid called cortisol, what it does is it creates glucose for us in a time of stress. So it provides energy for us in a stressful time. But remember, we still have this prehistoric software that's running in our body. So 50,000 years ago, we got stressed when we were being chased by a predator or we were being invaded by another tribe. So our stress in our prehistoric world, in our ancestral world, tended to be very short term. So that stress mechanism was important to create that short burst of energy so we can get away from that predator, so we can fight back, so we can flee. So those stress responses tended to be in shorter term. Now our stress responses, the Backstreet Boys broke up, and I'm heartbroken for weeks. Or Kanye divorced Kim Kardashian, or vice versa. We're stressed out about that. So our stress responses now tend to be very, very long-term and easily triggered. So if we have that stress response, remember that cortisol, one of the ways it creates this energy for us is it breaks down muscle. That's what cortisol can do. It can break down our muscle tissue. So remember, if we're more stressed or we're stressed over a longer period of time, then we lose muscle. And if we lose muscle, we lose the mitochondria. And if we lose the mitochondria, we lose this capability to burn fat. So stress is very important. To mitigate that stress is very important because that's what will help us maintain our muscle, if we can mitigate the stress. So let's look at, this is a graph I put together. This is 2 consecutive attempts at a crash diet. This is just hypothetical, but the illustration is very, very valid. So the first crash diet is the red, the second crash diet is the purple. So let's say somebody starts out at a body weight of 200 pounds, and in that 200 pounds, 150 of that is lean weight, 50% is fat weight, and that puts them at a body fat of 25%. So now they're 200 pounds and they say, I want to go on this very quick diet. So they're going to eat 500 calories or they're going to go on a tremendously low calorie diet. Let's say you lose 20 pounds really quick. And in that 20 pounds that you lost some fat weight, but you also lost this lean weight, lost 10 pounds of muscle and 10 pounds of fat. So now you're at 180 pounds and you're saying, okay, I lost 20 pounds. I'm going to go off this diet because it was unsustainable to begin with. So, and that's another thing. If somebody's on a diet and they start the diet and they're already thinking about when they're going to get off of this diet, that is not the sustainable path. And I understand people want to lose weight quickly, but the diet industry is a 95% fail rate. $60 billion industry, 95% fail rate. Crash diets, they just don't work long term. Long term, they don't work. So this person lost 20 pounds in a very short time. They lost muscle and they lost fat. So now they're 180 pounds and they say, all right, I'm going to go off of this diet. I'm going to start eating normally again. So now we gain 10 pounds back. Now, here's the key. We know that muscle is very hard to put on. So if we go on a crash diet and we gain 10 pounds rapidly, that 10 pounds is not muscle. We just don't gain 10 pounds back. That 10 pounds is typically in water and fat. So let's say the person goes up 10 pounds. Now they go up 10 pounds after the crash diet. They're now 190 pounds. Their lean weight, their muscle is still the same. But they put on 10 pounds of fat. So at 190 pounds, they're 10 pounds lower than when they started. But if you look at the body fat percentage, their body fat percentage went from, at 200 pounds, their body fat is 25%. At 190 pounds, 10 pounds less, their body fat is 26.3%. So the body fat is already higher at a less weight than they started. And what's the typical scenario? We gain all the weight back. So now we're back to 200 pounds, didn't gain muscle, we gained more fat. So now look at the first column and the fourth column. First row and the fourth row. At 200 pounds, we started this diet and we're 25% body fat. At the end of the diet, we're back at the same weight, but now our body fat went from 25% to 30% at the same weight. And that's why the scale doesn't tell us much. The scale just tells us how much gravity is exerting on you. It doesn't tell you what your body composition is like. So now somebody's back at 200 pounds and they're saying, oh, I got to go back on another diet. And then they do the same thing, the same pattern, and now at the end of the second diet, they went from 30% body fat to 35% body fat. So now they're the same weight. They started at 25% and now they're at 35%. And this happens over and over and over again. And that's why you'll have somebody who says, yeah, I'm doing great. I'm the same weight since high school. No, you're not. You're not really the same weight, because the true definition, the true measure is what's happening under the hood. What's your body fat looking like? What's your lean weight looking like? If somebody loses 10 pounds of muscle on a diet, that is a failure of epic proportions. We should not be losing our muscle. We got to keep it and maintain it for all the reasons that we talked about. So if we look at a graph, the red is the fat, the blue is the muscle. And on the crash diet, typically what happens is the fat goes down a little bit, but then it goes back up. And what happens with the muscle? It goes down, but it typically stays here. Especially if somebody's on a diet and their only concern is weight loss, and they're not concerned with building the muscle. Because remember, if you don't stimulate that muscle, it doesn't just come back. If we had the spontaneous growth of muscle, we'd all be supermodels and bodybuilders without doing anything. It doesn't happen. So that muscle tends to go down, and then it stays down. So the goal is we want to reverse these colors. If we have muscle and it goes down, we want it to get back up. And if that fat goes down, we want to keep it down. Any questions over here? We got about 5-10 more minutes. Okay, how do we measure this? This is very important. And let me get one thing, excuse me. I'm going to pass it around. Thank you. So one way we can measure, let me get here. So one way to measure your metabolism is by what's called direct calorimetry. So essentially you're a lab rat in a sealed box. And you're in a sealed box and everything is measured. The amount of food that you might take in, the amount that comes out of you, the humidity in the air, the temperature in the air, all of that is measured in a 24-hour period. And it tells you exactly how many calories you burn because it's a direct measurement. The problem is that these are very hard to find. There's only a dozen or so in the world, maybe 2 dozen in the world. They're very, very expensive. And most people don't have the capacity to sit in a box for 24 hours and live their life. So this is very, very hard to find. What I'm passing around is the output to something called indirect calorimetry. And this is a 10-minute breath test that measures your resting metabolic rate. So when I talked about my client who had the sky-high metabolism, this is what we use to measure her. And this is 98% accurate, 99% accurate. So to explain this, let me go back to the mitochondria. So remember, that mitochondria takes in oxygen and it expels carbon dioxide, and that determines how much energy we create. So if I can measure your oxygen and I can measure the carbon dioxide, so if I can measure the oxygen that you take in and retain, and I can measure the carbon dioxide and oxygen that you expel, that will tell me what the mitochondria are doing. That will tell me how many calories your body is creating. So that is the measure of your resting metabolic rate. It's a breath test that compares the amount of oxygen you take in versus the amount of carbon dioxide you expel. It takes that data, plugs it into a very complicated equation, and it tells you how many calories you burn in a day. And this is the highest technology. This is the most advanced technology we can find right now that's commercially available to measure your metabolic rate. And this is important because many people go on a diet, and think about it, if you went on a diet and you stuck to a certain amount of calories. Have you ever been on a diet where you said, I'm going to eat this many calories? No? Have you been on a diet? How many calories did you decide that you were going to eat when you went on that diet?
I don't remember calories. It was just like
Hand portion, okay. You know, a lot of people, they'll go on a diet and they say, well, I'm going to eat 1,200 calories. I'm going to eat 1,400 calories. And then I'll ask them, well, how did you get that number? And for most people, it's just estimation. They'll go on the internet, they'll put their stats into a web page or this calculator or a utility, and it'll tell them how many calories that they burn. But remember, that's just an estimate. An estimate, if we use an estimate to base our strategy, we can be off by a tremendous amount. My client who was burning 2,318 calories a day, she was 46%, she had a 46% higher metabolic rate than average. So what that means is if she put her stats, her age, height, weight, and gender, and she estimated her metabolic rate and how many calories she burned, it would give her a number that was 46% lower than she should be eating. And what that means is she would have been absolutely suffering because she would have been on a diet that did not give her the energy and the building blocks to sustain life. And that's why estimation is a problem, because it's just that. It's just a guess. It's just a prediction. So if we can measure it, then that's where the magic happens. And once I started measuring my clients as opposed to estimating, that's when amazing change happened. All right, I want to bust a couple of myths, and then we'll close, and I'll answer questions. All right, how many people have heard the myth that there's certain foods that can raise your metabolism? So when you eat that food, you'll burn more calories than you actually take in. Anybody heard of any foods like that? Okay. Well, a lot of people think that there are foods that can raise your metabolism, like celery, green tea, things like that. You would have to eat a dump truck worth of celery to burn a couple of calories. There are just no food. If celery was the key to losing weight because you burn more than you expel, we wouldn't be doing this. I would just say, eat celery. Where's my check? So there are no foods that can raise your metabolism to an appreciable degree where it's going to create these massive changes for you. Maybe in the technical sense, there might be something that raises it a calorie more than you expend. But on a general sense, there are no foods that are going to cause you to burn tremendous amounts of fat or energy more than you expended. How many have heard that you have to eat 3, 4, 5, 6 times a day to burn fat because you have to eat to stimulate your metabolism? Has anybody ever heard that before? A little bit. Okay. That is a big myth. A lot of people, because think about it. If the amount of calories I burn is based on the amount of times I eat, I should be able to just sit in a corner, eat 10 times a day, and burn all kinds of calories, and just eat myself thin. That sounds great, right? Not the case. And this is important. This is probably the most important slide of the day for individuals who are really thinking about winning that weight management battle. If you're familiar with insulin, you've heard of insulin? Insulin is the hormone that is released by the pancreas, by the beta cells of the pancreas, and insulin's job is to remove, well, one of its jobs is to remove carbohydrates, glucose, from the blood. Because if our blood sugar gets too high, it's very damaging in many ways. So when we eat carbohydrates, this insulin will rise in response. And that insulin will remove blood sugar, remove carbohydrates or glucose from the blood. And then once that glucose has been disposed of, and there's many ways we can store it, then that insulin will come down. So let's say we have 3 peaks here. And this refers to the 3 times you might eat during a day. So we have a breakfast, we have a lunch, and then we have a dinner. Now the key is that insulin turns off or down-regulates fat burning. So when this insulin is high, look at the other graph, your fat-burning hormones. These go low. So when insulin is up, we are turning off fat burning. So let's say we have our breakfast, and it's a typical carbohydrate breakfast. It might be, maybe a bagel, some fruit, things of that nature. We eat these carbohydrates. Those carbohydrates get converted to glucose. That glucose gets into our blood system, our bloods, and then that insulin, the pancreas senses the increase in blood sugar, secretes insulin. The insulin goes up to remove the sugar from the blood. And that sugar will go to muscles, it will go to our organs, it can go to fat. So when we eat our carbohydrate breakfast, its insulin is going to go up, and then eventually it's going to go down. Now, when that insulin goes back down to a basal level, now these fat-burning hormones, they say, all right, insulin's gone, we can start kicking butt. Now we're going to start burning fat. And then we have our second peak. Let's say we have another lunch with carbohydrates. The insulin goes up, and maybe it's not to the degree of the breakfast, but insulin goes up again, and then it goes down, and then it goes up. So the key is that when we have the peaks, then we don't have the fat burning. But when we have the valley, that's when the fat burning happens. So we have 3 peaks, 3 valleys. So what we want to see is we want to see these valleys, these long valleys, because that's where the fat burning is going to be at its maximum. So let's say, so that was the 3 meal a day model. This is the grazing model. So let's say we wake up and here we have our first peak, we have our breakfast. And then it's after breakfast, maybe it's 10 o'clock, 10:30, and we're going to eat something. We eat a piece of fruit or we have a smoothie. Guess what? That insulin goes back up. If that insulin goes back up, what happens to the fat burning? It goes back down. So now we have our lunch at our second peak, and then it starts going down, and then maybe we have that 3 o'clock crash, and then we have something else. We have another piece of fruit, or we might have some chips or soda, something like that. And then the insulin goes back up. The fat burning goes down. So you see there's no flat spots here. Look at the first graph. Insulin peaks, and then insulin valleys. And then fat burning is the flat spots. This is the grazing model where we're just eating little by little all day. And guess what? We don't have that fat burning. So when we're eating multiple times a day, it's the fact that we're potentially keeping our insulin up. And when that insulin is high, then that fat burning is at a minimum. So the peaks and valleys are very important. And that's why eating all day can stunt our fat burning. Very important. All right. I'm going to go into the summary and then I'll answer some questions. So think about when you're embarking on your weight management strategy, think long term, because when we go short term, remember, short term diet, we can lose our muscle. Short term anything is not very sustainable. We want to think about the sustainable path and not the quick and easy path. Low calories, not necessarily the answer. Maybe lower calories than you were, but the crash diets, the extremely low calories, not sustainable. And for certain people, for certain purposes, certain populations, maybe extremely low calories might work. But for the average person who wants to maintain their muscle, they want to stay fit and healthy, lowest calories is not the answer. Maybe a little bit lower than we're at. For some people, maybe we're increasing the calories to get our results. Increasing the calories from where we are. It depends. And what we found after working with thousands of clients is that the lasting change, the change that is more persistent and permanent, tends to be the changes that are easy to implement. So if we think about compounding interest, you put a little money in the bank and it just grows and grows and grows and grows. It's small changes that are compounded and repeated over and over, which leads to a very powerful change. If we implement a system and we can't maintain it, we might get quick results, but they very, very rarely last. So think about play the long game. And I know it's challenging because a lot of times we want to lose our weight very quickly, or we want to gain our weight very quickly. But let's say we're trying to lose weight. The weight that we gained, we didn't gain that a pound at a time. We gained that an ounce at a time. We gained that a gram at a time. So the same way we gained that weight, we want to lose it the same way. And that requires patience. It requires a strategy, a very important strategy. So think about that. Okay. I'm going to answer some questions. I have a couple of questions from Instagram. Let me read this and then we'll answer these. Are there any blood tests that can give us an insight into metabolism and guide us to eat foods that are right for us? That's a good question. So, one thing that's very powerful, so we mentioned the insulin and how this governs how much fat we're burning. It governs also a lot of other things in our body. One thing that we can do, and it's a very powerful test, it's called an oral glucose tolerance test, an OGTT. And what that does is that measures how much your insulin will rise and fall based on some carbohydrates that you take in. So for example, so the way an oral glucose tolerance test works is you'll sit down and you will get 75 grams of liquid glucose. And then it doesn't taste very good, but what it does is, so you'll drink the 75 grams of glucose, and then the blood test will measure how high your insulin goes up and then how high it stays up. So if you drink the 75 grams of glucose and your blood sugar goes up, actually, let me rephrase that. The oral glucose tolerance test measures how high your blood sugar goes up and how long it stays up. There are other more precise oral glucose tolerance tests where you can measure insulin and how it rises, but I found that those are hard to find. So let's say you've taken 75 grams of glucose and your blood sugar goes up to 130 milligrams per deciliter, and it stays that way for a long time. That is a measure of the fact that your insulin, either you're not producing enough or that insulin is not effective, and that's what we call insulin resistance. Whereas if you drank 75 grams of glucose and your insulin and your blood sugar went up and then it went down pretty quick, that's a sign of a more healthy functioning. So that can tell you how you're processing your carbohydrates. And insulin resistance is a very strong predictor of metabolic dysfunction down the line. So that's one of the biggest things that you could take, is the oral glucose tolerance test. You have to ask your physician for that because most people don't know what it is, but it's very powerful. So that's the one I would recommend. In terms of if they guide us to eat the right foods, that test will tell you how you respond to carbohydrates. And there are some tests, there are some oral glucose tolerance tests where instead of drinking 75 grams of sugar, what you could do is they'll say, well, what's your typical breakfast? And they might say, well, I eat a bagel and then I drink orange juice. And I say, okay, well, come in, eat your typical breakfast, and then they'll measure what your glucose is. And what they do is they measure a baseline glucose, then they'll measure it at 30 minutes, and then 60 minutes, and then 90 minutes, and then 120 minutes. And they'll tell you what that glucose excursion is. So that'll tell you if you're carb sensitive. Maybe if this oral glucose tolerance test, if that shows you that you're insulin resistant, that's going to tell you, hey, maybe eat less carbs, or change your muscle mass, which gives you an increased storage depot for your carbohydrates. So that's a great question. I hope I answered it. The second question, how big of a factor is age for your metabolism? And that's a great question. You know, there is age-related decline of muscle. There's age-related decline of activity. Maybe we're less active. So it's hard to say whether your metabolism is decreasing because you're aging, or is it because you're losing muscle mass because you're aging, or maybe it's not the aging part that's causing us to decrease in muscle. Maybe it's just the fact that whatever stage in life we're at, it's not the age, we're just doing something different. Maybe we have more injuries, so we're less active. Maybe we have more priorities in life. So there is a general trend that as we age, metabolism decreases. But it doesn't mean that as you get older, you're definitely going to lose your metabolism. Because let's say you get somebody from the time they were born to age 50, they were just a sedentary couch potato, didn't exercise, didn't do anything. And then at age 50, they have an epiphany and they say, you know what, I gotta change everything. I'm gonna work out, I'm gonna build muscle, I'm gonna sleep well, I'm gonna eat the best foods. From 50 to 70, that person's metabolism might go up because they've changed everything. So if everything is kept equal, yeah, there's probably gonna be a trend. There's probably gonna be a correlation between age and metabolism, but it doesn't mean that you cannot reverse the trend based on activity, based on your lifestyle. So whether you're aging or not, it's all about evaluating what you're doing and how do you optimize that? How do you optimize your sleep at age 55? How do you optimize your exercise? People can build muscle well into their 60s and 70s. So I just wouldn't want to make it a blanket rule that we're aging and our metabolism is decreasing. We can increase it, we can change things. And can your rate of metabolism change over time? For the things that we talked about, absolutely, your rate of metabolism can change over time. If we don't do anything, yeah, it's probably going to decrease. But if we embark on strategies to reverse that, yeah, it can increase, absolutely. Good questions. Any other questions? No. Okay. Well, question.
Can you burn protein?
Can you burn protein? The technical answer is yes. Your body does not want to burn protein. Your body will only burn protein if there's a good reason. So if you're extremely low calories, and that's why we want it, sometimes a low carbohydrate diet, it's so low in calories that our body will dip into the muscle. So your body can do it, and we don't want that to happen. So technically it can, because there are certain amino acids that are called glucogenic amino acids, and those amino acids can get converted to carbohydrates.
So fat weighs less than muscle.
Well, when you say weighs, what do you mean? A pound of fat and a pound of muscle weighs the same. So when you say...
Well, when you're talking about the bucket analogy, you're saying that the lighter bucket versus the heavier bucket. More energy, less energy. Fat is lighter, muscle is heavy because it has water.
Yeah, so when you compare it to gram for gram, energy for energy, so calorie for calorie.
Oh,
if,
right. Calorie-wise, there's, right, fat is...
Yeah, so basically, it might take, and I'm not, don't worry about the numbers right now, but it might take you, if you had a pound of fat, that might yield you 3,500 calories, okay?
Right.
If you had a pound of carbohydrates, because it's going to be stored with water, that might only yield you 400 calories. So it's not that a fat cell weighs more than a muscle cell. It's that when you standardize across calories, it's going to take less fat weight to make more calories. Does that make sense?
Yeah,
Okay. Okay. Is there another question, Yuki?
Yes.
Can you read it to me, please?
Okay. It seems like intermittent fasting may be beneficial for fat loss due to the drop in insulin. What are your thoughts on this?
That's exactly right. That's a great point. So intermittent fasting, imagine, do I have a slide with this? Yeah, okay. Intermittent fasting, let's say somebody eats one time a day. This is what they're looking for. All right, so remember the flat spot is when the insulin is low and the fat burning hormones are high. So now, if we eat once a day, then we get this huge insulin spike and then we get down. So we're maximizing the amount of fat burning hormones we have and we're minimizing the amount of insulin. Absolutely true. Now, intermittent fasting is a tool just like anything else. Like, we have a lot of tools. Keto diet, paleo diet, intermittent fasting, they're all tools. And with every tool, we got to think about, is that tool the right for us to use? And if it is, how do we use it? How do we implement it? You know, I have a chainsaw, I could use it to cut down a tree. I could also use it to cut butter. You know, it's going to get messy around breakfast time, but I could still do it. So we got to figure out, is intermittent fasting the right tool? So one way this might not be the right tool is because this insulin, even though it turns off fat burning, what's important is insulin is a very powerful growth factor. It's very anabolic. So we need insulin to grow. So we'll grow our muscles. Unfortunately, it grows everything. You know, our fat cells grow and our organs can grow. So if somebody is looking to build muscle, and that's their highest priority, building muscle, this might not be enough insulin in their day to build that muscle. I had one client, he was on a intermittent fasting regimen. He was doing 19-5. So he was doing 19 hours of fasting, 5 hours of eating. So he had a very, very small insulin peak, and then the rest of it was fat burning. And he was in his 60s, or is in his 60s, and he was having a hard time building muscle. And we talked about the relationship of insulin to building muscle. So what we did was just extended this peak. Instead of a 19-5, he went on a 16-8 or something like that. So he had more insulin that he was producing, and it put him more in an environment to build and maintain and stimulate muscle. And it worked a lot better for him. So it's just a tool. If somebody's looking to lose weight, intermittent fasting has helped a lot of people. Now, there are a lot of people that intermittent fasting, put it this way, for every diet that you've heard of, paleo, keto, low carb, there are many people who are wildly successful at it, and there are many people where it was an abject failure. So it's not the diet itself that is the arbiter of whether you're going to get success. It's how you implement that diet. No diet comes ready out the box for you or you or you to implement, because you all have different calories, you have different metabolic rates, you have different muscle mass compositions, you have different activity levels. So if we were all on intermittent fasting, we all have to tweak that diet for us. So while for somebody who was trying to lose weight, this might be very helpful, for somebody else, they can't just pick up the ball and run with it. You gotta be very strategic about it. So, but it's a good question. That's exactly right. Insulin is mitigated very well when it comes to intermittent fasting. Yeah.
And when we talk about intermittent fasting, what's like the range of hours? Like, would you call like 12 hours intermittent fasting? Would you call it 8 hours? You know what I mean?
Yeah, I mean, so 12 hours is essentially what everybody does, right? You eat dinner at 8, and then maybe you go to bed at 10, and then you wake up at 7. That's basically 12 hours right there. So 12 and 12, that's usually not intermittent fasting. What I've usually heard is it usually starts at 16:8. So it's 16 hours of fasting, 8 hours of eating. That's where I've heard it usually start. Usually 12 and 12, most people can pull that off. So 16:8, yeah.
I got a question.
Yes, sir.
So eating is kind of like a training too, right? Eating the right amount, eating the right food is a training, in my opinion.
Mm-hmm.
If you keep eating, like, say, high-fat food, like nuts and stuff like that,
Mm-hmm.
do you think your body is going to be more efficient in burning fat more than sugar?
Yeah, that happens, absolutely. There are people who have been on a ketogenic diet for so long that they become fat adapted, and their body becomes more efficient at burning fat. And that's what happens. Whatever we do, our body tends to make this shift, first in an enzymatic level, and then in an epigenetic level. So we get these, what's called transcriptional factors, where our genes are affected based on how long we do something. And that's why sometimes if we go on a diet or we make a change, we have to back out of these long-term changes that our body made at an epigenetic level, on a transcriptional level. Our body has to back out of that. So just if we have told our body that its only fuel is carbohydrates, then it is going to adapt itself in more permanent ways to burn carbohydrates. And then if we try to change that, we kind of have to back out of that. So yes, your body becomes adapted pretty much to anything you do. And like you said, it's exercise as well. Just like if we're doing exercise, we want to change up our exercise because our body may get adapted to that. So yeah, absolutely. It's like exercise. Yeah. All right, I think I kept you all long enough, and we're going to close, but I'll be here to answer any questions. And thank you all for being here. Appreciate that. All right.
Wow, that was great.
Thanks. Any questions that we're not on camera now?
I was actually going to bring up the fasting, but I wasn't.
You can bring it up now.